Hello everyone, good afternoon and welcome to my channel Aptitude Club. Hope all of you are doing well. Today in this session we are going to discuss a question on the topic permutation and combination. This is from that area, and this question specifically involves the principle of fundamental principle of counting, and very important question. It was a previous year question, and we'll try and see how we can solve this question, what concepts can be applied here, and in what way this question like should be approached so that you can solve it in a very easy process. All right, and those of you who are watching the video at this point, I'll request to pause at the moment and try the question yourself first, then look at the explanation. So let's start. How many 5-digit numbers are there such that the digits are the hundreds place, units place, and 10,000 place? Form a geometric progression. So if I'm talking about 5-digit number, so 5-digit number would be like this: A, B, C, D, and E. So this is the units place, this is the tens place, this is the hundreds place, this is the thousand place, and this is the 10,000 place. That is how the places are. Question is saying the digits are the hundreds place, unit place, and the 10,000 place. It forms a geometric progression, not necessarily in the same order. That means I can say A, C, and E, they will form a geometric progression. A, C, and E will form a geometric progression. So how many such possibilities are there? Now clearly we need to understand what geometric progression is to be able to solve this question. Now, what is a geometric progression? It's a series of numbers where every subsequent number appears at a constant ratio. For an example, if I'm taking a GP, suppose I'm taking 2, then 6. So 2, I'm multiplying 3 to get the next number 6. I'll again multiply 3 to get the next number, that is 18, and again multiply 3 to get the next number, that is 54, and so on. This type of a series or a progression is called as a geometric progression, where you multiply a constant to reach the subsequent number, and so on. It continues like that. So A, C, E are in geometric progression, and this constant that you multiply, this 3 here, is called as the common ratio. Now A, C, E are essentially digits only. That means the question boils down to this, that how many groups of 3 digits can I take such that they will appear in a geometric progression. So the first case, case 1, is when I'll take the common ratio as 1. Common ratio is 1. So my digits can be 1, 1, and 1. These three terms are in geometric progression with common ratio 1. I can take 2, 2, and 2. Same digits ही ले रहा हूँ, and the common ratio in this case will be 1, 3, 3, and 3, 4, 4, and 4, 5, 5, and 5, 6, 6, and 6, 7, 7, and 7, 8, 8, and 8, and 9, 9, and 9. So the 0 to 9, although I have 10 digits, but I can't have a 0 in the first place. So 9 possibilities and 9 such groups of 3 digits I can make where they are in geometric progression. Suppose I pick any one case. Suppose I am picking this case. So using one case, how many such numbers can I put? So 5-digit numbers, so 1, 2, 3, 4, and 5. In the 10,000s place, hundreds place, and units place, I am putting 1, 1, and 1. Geometric progression. The remaining two places, that is the tens place and the thousands place, it can be filled up in 10 ways. 10 ways. This 10 signifies 10 ways. Any digit from 0 to 9 I can put. Same here also, 10 ways. And any digit from 0 to 9. That means for each case, suppose I am putting 1 in the 10,000s place, and then hundreds place, then units place. 1, 1, 1. This part is fixed, but these two digits, the way you can change it, that many different numbers. For an example, I can have 1 2 1 2 1 if I am putting 2, or I can have 1 3 1 2 1, or I can have 1 0 1 5 1, I can have 1 0 1 7 1, 1 9 1 0 1, and so on. You can have different numbers like this. 1 1 and 1 are fixed, that like middle two digits you can change based on what digit you are considering. So how many such cases can be made? 10 possibilities here and 10 possibilities here. So 10 into 10, I will have 100 possible numbers for each case. Hence I have 9 cases, so 9 into 100, I can have 900 numbers here, because every case will give me 100 numbers. Doesn't matter you take 111 or 222 or 333, in each of the cases you will have 100 numbers each. So 9 cases, 900 numbers, when I am considering the common ratio to be 1. This is the first part. But common ratio 1 is easy. What can be other values of the common ratio? Case 2, when common ratio is not equal to 1. Now this part is a little tricky. The 3 digits could be 1, 2 and 4, where the common ratio is 2. I can take 2, 4 and 8. I will only like take digits. I cannot take numbers. You cannot take 10, 12. Those are numbers. They are not digits. A, C and E are digits. So 2, 4 and 8, again common ratio is 2. I can take 1, 3 and 9 also. Common ratio is 3. The last case, there is one more case, and this is the case why the question like is designed, because probably a lot of students or a lot of people will skip this one, because it doesn't strike immediately that the digits 4, 6 and 9, these three digits are also in geometric progression with a common ratio of 1.5. Okay, very important. This is something you don't usually think of. 4, 6 and 9. 4 into 1.5 is 6, 6 into 1.5 is 9. So I get 4 cases now. Again, like the previous one, let me take any one of the cases. So 5 digit numbers, 1 2 3 4 5. Let me put 1 here, 2 here and 4 here. So these two places can be filled up in 10 into 10 ways. So 10 into 10, again I should get 100 numbers, but the catch here is it is not necessary that 1 2 and 4 will be fixed at these three places. 1 2 4, it could be 1 4 2 also, it could be 2 1 4 also, and so on. So these three digits 1 2 and 4, these three digits can be arranged in 3 factorial ways. There are 3 places for them and 3 digits, so you can arrange it in 3 factorial ways. 3 factorial as in these are the arrangements. Either you can take the order as 1 2 4 or 1 4 2, 2 1 4 or 2 4 1, 4 1 2 or 4 2 1. There are 6 possibilities, because question said not in any specific order. So I can take it in any order I want, just they should be in geometric progression. Doesn't matter what order you are taking. In the previous case, because all the digits were same, you cannot change the order really, because it will give you the same result every time. Here the digits are different, so if you change the order, you will get a different number. So the middle digits can be filled in 10 into 10 100 ways, and the 3 digits that you have selected, they can be arranged among themselves in 3 factorial ways. Hence total, I'll get 3 factorial into 10 into 10. So you get 600. So 600 for one case. So I have 4 such cases. Hence 4 into 600. You will have 2400 numbers, because every case will give you 600 numbers. 1 to 4 you will have 600 numbers. 2 4 8 if you take another 600 numbers, and so on. Hence in total, combining case 1 and 2, you will have 900 plus 2400, 3300 possible 5 digit numbers, where those 3 digits are the unit place, 100 place and 10,000 place, are in geometric progression. I can have total 3300 numbers. So this is a beautiful question from fundamental principle of counting. Now if you carefully look at the options are also very tricky in this, because if I miss out this last case, Suppose you are missing out on this last case, 4, 6 and 9. You will have only 3 cases. So you will be falling 600 short of your answer. And you see 2700 is also there in the option. But this will be a wrong answer. If you miss out on the arrangement, suppose you miss out on the arrangement, 3 factorial you are not considering, 1, 2 and 4. So you will only take 600, sorry not 600, 100 each case. You will not multiply this 3 factorial, that is 6. So you will say 100, 100, 100, 100, 400. And 900 plus 400, you will think that 1300 can be your answer. And you see that is there also in the option. That is also wrong. So questions sometimes are asked that way, that you will see the options are also tricky. The most likely mistake that a candidate can do, those kind of options can also be present. So we need to be very careful when we are solving such questions. I'm not saying this kind of questions only come from permutation combination. It can be any topic. Okay. So when we are thinking about a question, we should read very carefully, because at the end it was written not necessarily in the same order. That means I can change the arrangement of digits. Okay, very carefully we'll have to read the question, and then the process is simple. Fundamental principle of counting, no complicated formula and anything is used here. So I hope all of you understood the explanation of this. Very good question, small question but important. All right, and if you watched it this far, I hope you liked the explanation and enjoyed the question. Do subscribe to the Aptitude Club channel and explore the previous videos that I've done on this channel. You will definitely find them useful. Do watch out for the QA booster playlist. You will get some good questions to practice for your CAT preparation, and we'll meet again very soon on yet another video. Till then, keep solving, keep studying, and thanks for watching. Bye bye.